Okay, sorry guys, we seem to have lost the internet connection. But what we were saying is, in the non-relativistic particle mechanics, we had these two red equations. They hold on a given slice because left-hand side and right-hand side only refer to quantities at a given t, so they're quantities living on that slice. The second boxed equation was the equation that we would use to quantize the theory. And I was saying that H bar appears in that equation, and I wanted to stress that this is really where H bar is put into the theory. It's from that second boxed quantization condition. Okay, so now let's extend this to quantum field theory. So what would we have? Well, we would again have to define a conjugate momentum. Oh, before we do that, for each slice now, we would have a Fock space associated to each slice. So I've called the Fock space curly F. This is associated to each slice. What would the Fock space be? It would be a direct sum of many Hilbert spaces. Each of those would have a definite particle number. We would also need to define our conjugate momentum. So we'd have pi of t comma x, that's t comma x. This would be given as a derivative of the Lagrangian density with respect to phi dot of t and x. And what you'll notice again is that this only refers to quantities defined on a specific slice. We would again quantize the theory by stating what the commutator is. So again, this is the equation that defines our operators for us. And they again are defined at some specific time. It's minus I h bar and a delta of x minus y. So once again, these two equations that I'm boxing now, these are defined on a specific slice, and it's that second boxed equation that really puts h bar into the theory. So this is the idea behind the standard quantization, and the thing that I want you to see is that time is playing a special role. It's defining for us our constant time slices. Those are associated either to a phase space, or to a Hilbert space, or to a Fock space. On each slice, we define our conjugate momenta, and on each slice, we write down a quantization condition. Great. We'll continue in a moment.